PPT வருது.
Okay, the session topic is quantum gates and the quantum circuit design for programmers. Let us start with the introduction. Quantum computing is a groundbreaking field that merges quantum mechanics with computer science. This section includes programmers to the fundamentals concept of quantum computing, mathematical background, which is required to understand quantum computing. Then we are going to discuss about qubit and superpositions, followed by quantum gates, and then circuit design for quantum programming, applications of quantum computing, and finally, we are going to discuss about the challenges in the quantum computing. So this is the overall layout of this presentation. Whether you are a developer or a new programming, whether you are a developer or new to programming, understanding quantum computing is critical, crucial for achieving, crucial for achieving very high speed computing.
Video ஆஃப்ல இருக்கா?
என்னோட வீடியோ இல்லையா சார்?
ஓகே. இப்போ ஆன்ல இருந்துச்சு. நான் வாட்ஸ்அப்ல ஒரு யூடியூப் லிங்க் அனுப்பிச்சிருக்கேன் பாரு.
ஆமா.
லிங்க் உனக்கு வருதா பாரு.
லிங்க் ஓப்பன் ஆகுது, இருங்க. நான் அந்த மொபைல பார்த்துக்கிட்டு இங்க பிரசன்டேஷனை போடுறேன். ஃபர்ஸ்ட் ஒரு 5 மினிட்ஸ் கொஞ்சம் திணறுன்னு நினைக்கிறேன். அப்புறம்
பரவாயில்ல. பிராக்டிஸ் தானே.
ஃபர்ஸ்ட் ஒரு 5 மினிட்ஸ் கொஞ்சம் திணறுன்னு நினைக்கிறேன். யூடியூப்ல இருந்து கொஞ்சம் ஸ்லோ வருது இல்லைங்க சார்?
ஆமா, ஒரு டிலே வரும்.
Okay, let's start with the introduction. Quantum computing is a groundbreaking field that merges quantum mechanics with computer science. This section introduces programmers to the fundamental concepts of quantum computing, mathematical background, which is required to understand quantum computing, qubit and superposition, quantum gates.
PPT full view.
Oh.
F5.
Then we can discuss about the quantum gates, circuit design for quantum programming, and then applications of quantum computing, and finally, the challenges in quantum computing. Whether you are a developer or new to programming, understanding quantum computing is crucial for achieving very high-speed computing. First, we can discuss about the fundamental concept of quantum computing. What is quantum computing? Quantum computing uses the principles of quantum mechanics to process information. Unlike classical computers that use bits such as zeros and ones, quantum computers use quantum bits, or we can say qubits, which can be in a state of 0, 1, or both simultaneously, that we can call it as superposition. This property, along with entanglement and quantum interference, enables quantum computer to solve complex problems much faster than their classical counterparts. Programming for quantum computers presents a set of unique challenges and opportunities compared to classical programming. Here are some key differences. Qubit manipulation. Unlike classical bits, qubits can exist in a superposition of states. Programming involves manipulating these superpositions and entanglements. Quantum gates. Quantum algorithms use quantum gates instead of classical logical gates. These gates operates on qubits and are the building blocks of quantum circuits. Noisy intermediate scale quantum era, shortly NISQ era. Current quantum computers are prone to errors and have limited qubits. Programming, that is, programmer must account for these limitations. Then the next key point is quantum entanglement. Leveraging entanglement in programming is both a challenge and a source of quantum computers' power. The next key differences with the classical computer and this quantum computer is the hybrid systems. Many quantum algorithms involve hybrid systems that use both classical and quantum computer together. This unique environment opens up new possibility in various fields such as cryptography, material science, and complex system simulation. Now let us discuss about programming languages available for quantum computing. Programming quantum computers differ significantly from classical programming. Quantum algorithms are designed to take advantages of qubits properties. And quantum programming languages like Q# and Qiskit are used to create these algorithms. Here we have a list of languages through which we can develop quantum algorithms. First language is Q#. It is developed by Microsoft that is useful in integration with classical code allowing for hybrid quantum classical applications. Qiskit is alternative language developed by IBM. So it is an open source platform. Anybody can access through online and they can work with it. So this open source platform with extensive libraries for quantum computation and simulation. Then the third choice is Forest, developed by Rigetti company. It is designed for hybrid quantum classical computing with a focus of quantum cloud services. And finally, a well-known language is Circu, developed by Google, and it is developed for designing, simulating, and running quantum algorithms on Google's quantum processors. Let us see all these in detail. First, we can discuss about the Q#, which is developed by the Microsoft. So Q# is a language developed by Microsoft as part of its quantum development kit. It is designed to be used in conjugation with classical programming languages like C# to create hybrid quantum classical applications. The beauty of this Q# is the syntax and the overall programming structure will look somewhat similar to C#. The programmers, those who know C#, can easily adapt to the Q#. And the Q# emphasizes and seamless integration with existing .NET applications, make it easier for developers with a background in conventional programming to transit into quantum computing. And about Qiskit, an open source quantum software framework by IBM. IBM's Qiskit is an open source quantum computing software development framework. It allows users to write quantum algorithms in Python, a popular programming language. So Qiskit is known for its extensive libraries that cover various aspects of quantum computing, from basic quantum circuit design to complex algorithms and simulations. So Python is already very familiar in data science. The people, those who are working with data science, they are choosing Python. And this Python, previously people used for artificial intelligence, machine learning related works. So those people may feel easy to adapt Qiskit since the Qiskit uses Python libraries. Forest. It is a quantum software developed by Rigetti. The Forest developed by Rigetti Computing is a quantum programming environment that focuses on quantum classical hybrid computing. It includes COIL, The abbreviation of QIL is Quantum Instruction Language, a language for specifying quantum circuits, and PyQuil, a Python library for building and running these circuits and quantum simulators and quantum processors. And last is the CirQ. The CirQ is a Google's framework. CirQ is a Python library developed by Google for writing, manipulating, and optimizing quantum circuits. It is especially designed to target Google's quantum processors. CirQ supports the creation of quantum algorithms from the ground up and is particularly adept at handling noise and errors, which are common issue in current quantum computers. Now we are going to have a set of, now we are going to discuss about the mathematical background. To understand the quantum computing and quantum processing, we should be very strong in the fundamental mathematical concepts like addition and subtraction of complex numbers, multiplication of complex numbers, finding complex conjugate, multiplying a complex numbers with its conjugate, representing complex number on the number plane, and we should know how to measure the magnitude of a complex number, and we should know representing complex number in a polar form. We should know how to represent complex number in exponent form, and converting the complex numbers into polar form and exponent form. So starting from this till the Hermitian matrix, eigenvectors and eigenvalues, all these concepts must be well known to understand the quantum computing. Almost some 20 topics are here. Okay, let us discuss this mathematical background one by one. First, we can discuss about an imaginary and complex numbers. What is an imaginary number? Let's start with a question. X square is equal to 4. It is an equation. Is it possible to find the x value? Yeah, it is possible. So we can solve it by assigning x equal to square root of 4, and the square root of 4 can be simplified as a real number 2. So we can say the answer x equal to 2. It is simple. But if the x square equal to minus 4, if it is the equation, then what will be the answer for x? The possible x answer will be plus or minus square root of minus 4. That can be, sir, இப்ப பாருங்க, நான் mouse move பண்ணா mouse அங்க தெரியுதா பாருங்க.
இங்க இப்ப mouse x equal to plus or minus root minus 4 போடுறீ mouse. X
okay,
equal to
x square is equal to minus 4. If it is the equation, what will be the value of x? The x can be solved as x equal to plus or minus square root of minus 4. Since it is a negative number, we should use, we don't know whether the result will come in positive or negative. Two possible answers are there, so that we can write plus or minus square root of minus 4. And this can be simplified as plus or minus square root of 4 into square root of minus 1. In mathematics, we can take square root of minus 1 as I. So we can substitute square root of minus 1 as I, then we will get x equal to plus or minus 2i. I is the imaginary part. So now the plus or minus 2i, it is the example for imaginary number. So this is how the imaginary number comes. What is a complex number? If a number contains both real number plus imaginary number, then it is called as complex number. Sample complex number is as follows: a plus ib, where a and b belongs to the real number with capital R, and here a is a real part and b is an imaginary part. Imaginary part is represented by the I. And let us have an example. 2 plus 3i. It is a complex number. How? Because it has a real part and then we have a imaginary part. So imaginary part plus real part. So we can say it is a complex number. And let us take another example. Square root of 2 plus I square root of 3. This is also an example for complex number. Here square root of 2 is the real part and the square root of 3 is an imaginary part. And finally, we can have one more example for better understanding. Sometimes the number can be -1 minus I. So here along with I, no number is there, which means there is a 1. So we can take -1 as a real part and -1 as an imaginary part. Now we should know how to add complex numbers. We know how to add a normal number, that is very common. But adding this complex number is somewhat different. Let us see what it is. So let us take two complex number, say for example 2 plus 3i, and we can take another complex number, say for example 4 minus 8i. Let us try to add these two numbers. How we can add? It is very simple. We can add real number of the first complex number, and we should take the real part of the second complex number. Both the values must be added. Here in our example, 2 plus 4. 2 is the real number of first complex number, and 4 is the real part of second complex number. And that should be added with the imaginary part of the first complex number must be added to the imaginary part of the second complex number, that is 3 plus minus 8. So 3 plus minus 8 must be added. That will become a resultant imaginary part. So now 2 plus 4, that is 6, and 3 plus minus 8, that is minus 5, and I is there. So by adding 2 plus 3i along with 8 minus I, the result will be 6 minus 5i. This is also a complex number. Let us take one more example for better discussion. Let us take two complex number. One is 1 plus 9i, and the second number is minus 3 minus 8i. Let us try to add these two. So let us take the real part 1, and we can add with the real part minus 3. So 1 plus minus 3, this we can take it as a real part for the result. And we can add the imaginary part 9 with minus 8. So 8 can be added. That result will be taken as the imaginary part of the result. So finally we will get minus 2 plus I. 9 plus 8i, that is nothing but just 1i. So we can write 1i as I. So minus 2 plus I is the result we got by adding these two complex numbers. Now let us discuss the subtraction of complex number. It is very simple, which is very similar to the addition. We can take two complex numbers and we can perform subtraction between part and imaginary part with imaginary part. So for example, here we can take 4 minus 2 plus 3 minus 7. So by solving this, we will get 4 minus 2, that is 2, and 3 minus 7, that is plus 10. So minus typing mistake நினைக்கிறேன் சார், check மாத்திக்கலாம். சார் இருக்கீங்களா, போயிட்டீங்களா?
இருக்கு சொல்லு சார்.
சரி, ஓகே. என்னன்னா பண்ற ட்ரையல் தான் பார்த்தேன். ஓகே, நல்லா பிராக்டிஸ் பண்ண போல அங்கங்க கொஞ்சம் திணறுது.
உங்களுக்கு யூடியூப் லிங்க் அனுப்பிச்சிருக்கேன்.
பார்த்து யூடியூப் உள்ள மொபைல் ஓடிட்டு
தான் இருக்கு. அது சேவ் ஆயிடும்.
ஓகே, ஆட்டோமேட்டிக்கா சேவ் ஆகுமா?
சேவ் ஆயிடும்.
சரி, அதை நீங்க டெலீட் பண்ணிடுங்க இப்போதைக்கு.
அது நான் சேவ் பண்ணும்போது பண்ணிப்பேன். இப்போதைக்கு ஒரு 2 நாள் இருக்கும். என்னுடைய லாகின்ல தான் இருக்கும். பப்ளிஷ் பண்ணேன்.
சரி. சரி சார், இனியா வாய்ஸ் கிளியரா இருக்கா?
கிளியரா இருக்கு சார்.
சரி சார். அப்ப இயர்ஃபோன் போட்டே நான் பேசுறேன் நாளைக்கு.
சரி சரி சார். ஆல்
ஓகே
தி பெஸ்ட்.
பார்ட்டிசிபென்ட்ஸ் எங்க ஆல் தி பெஸ்ட். இதே நீங்க நல்ல டாபிக் எனக்கு தெரிஞ்ச டாபிக் கொடுத்துருந்தீங்கன்னா பட்டாசு கிளப்பிடலாம்.
என்ன பண்றது?
பரவாயில்ல சார், ஒன்றும் பிரச்சனை இல்லை.
ஆ
சரி, இது பாருங்களேன், இந்த பிபிடி ஆர்கனைசேஷன் இப்படி இருக்கு. மேத்தமெட்டிக்கல் கான்செப்ட் இவ்வளவு இருக்குல்ல, இது எல்லாத்தையுமே ரீட் பண்ணிட்டு போய் அது ஜஸ்ட்
அப்படியே எல்லாம் ரீட் பண்ண தேவை. அப்படியே நீங்க ஓரலாம் சிலதெல்லாம் அடிஷன்ன்றது ஒன்று சொல்லிட்டு மத்தெல்லாம் அப்படியே கொண்டு போகலாம்.
ஆக்சுவலா 1.5 மணி நேரம் வரணும் இல்ல, 1.5 மணி நேரம்
1.5 மணி நேரம் வரும்போது கொஞ்சம் நான் அப்படியே ஓட்டு.
இப்ப திடீர்னு இப்ப வந்துட்டு இதுக்கு போறேன், டெமோ போறேன்னு வச்சுக்கோங்களேன். Let us try to create the quantum circuits through online அப்படின்னு சொல்லிட்டு நான் இதுக்கு போறேன். So there is a website.
Online website வச்சுக்கோ. Okay,
so by opening this so through this website we can test all the gates what we have discussed, and also we can create quantum circuits as per our need. So let us have a small testing here, small practice here. So அந்த மாதிரி கொஞ்சம் ஓட்டலாம். ஓகே, இது நல்லா கிளியரா வருதா சார்? வியூ இருக்குங்களா?
வருது கிளியரா வருது.
ஓகே சார். சோ நான் என்னன்னா அந்த
மொபைல் இருக்கும்போது கொஞ்சம் எல்லாம் மொபைல் தான் மேக்ஸ் யூஸ் பண்ணுவாங்க, ஜூம் பண்ணி பார்த்துப்பாங்க. எனக்கு லேப்டாப்ல இருக்கு, மொபைல்ல வரும்போது சின்னதா வரும் இல்லையா, அவங்க ஜூம் பண்ணி.
சரி விடுங்க, மேக்ஸிமம் 90% கவனிக்க மாட்டாங்க எனக்கு தெரிஞ்ச யாரும்.
99%.
ஆமா, நபிசா பேகம் மேடம் இருக்கிற வரைக்கும் ஏதாவது கொஞ்சம் 10 நிமிஷம் பார்ப்பாங்க. அதுக்கப்புறம் படிப்படி எல்லாம் காணாம போயிருவாங்க.
இல்ல ஃபீட்பேக் கடைசி வரைக்கும் கொடுக்குவாங்க, அதை வெயிட் பண்ணுவாங்க.
சரி, அந்த வெயிட் பண்ற கொஸ்டின் 1 or 2 क्वेश्चंस கேட்கும்.
அது ஒருத்தர் கேட்பாங்க, அவ்வளவுதான்.
சரிங்க சார். நான் இப்ப என்ன தெரியுதுன்னா, நான் ஒரு 2 or 3 டைம்ஸ் வந்து பிரசன்டேஷன் முன்னாடியே நல்லா இது பண்ணுவோம், படிச்சு பார்த்து வச்சுக்கணும். டேர்ம்ஸ் எல்லாம் புதுசு இல்ல.
ஆமா.
சரிங்க சார்.
சரி,
ஓகே சார். குட் நைட் சார்.
குட் நைட்.